Welcome to Breaking News to Trading Moves. Today, we're focused on a specific announcement in the tech world. We want to look at the immediate winners and losers in market sentiment around quantum computing based on this news.
Exactly. And for anyone tracking how quantum tech might actually become, commercial, these early steps, these integration points, they're really quite telling. They often guide where investment goes now and who seems to have a clearer path to making money down the line.
Okay, so the headline itself. It's about IBM and Advanced Micro Devices, AMD, speeding up hybrid quantum computing development. And this isn't just some vague plan, right? It's tied to a specific technical achievement.
That's right. It's a concrete data point, which the field always needs. IBM announced that a key quantum error correction algorithm, and this is really fundamental for making quantum computers useful, is now running in real time. And it's running on standard AMD FPGA chips.
Right, FPGAs. And the speed part is what really jumps out. The reporting suggests this algorithm is running, 10 times faster than the quantum system actually requires?
10 times. Yeah, that's a big margin. It gives, immediate tangible support for IBM's roadmap, which is pretty ambitious. They're aiming for a fault-tolerant system. They call it Starling, aiming for 2029.
Okay, let's pause on fault-tolerant. We hear that term a lot. For listeners maybe newer to this, why is fault tolerance so crucial, kind of the end goal here? And how does this speed thing help get to Starling?
Well, fault tolerance basically means the system can find and fix errors faster than new ones creep in. Quantum states are incredibly delicate. Noise is everywhere. So without that fast real-time correction, the whole computation just kind of fizzles out, becomes useless pretty quickly. This milestone shows that the classical part, the control layer, checking for errors, can actually keep up. It sort of validates this whole hybrid idea, the idea that you don't need perfect qubits right away. Maybe you can bridge the gap to useful computation using this mix of classical and quantum.
Got it. So it makes the hybrid path look more practical sooner. All right, let's talk winners then. Companies whose strategies seem validated by this focus on near-term wins, combining quantum with existing hardware.
Well, IBM obviously has to be top of the list, ticker IBM. This backs up their timeline, sure, but also their whole strategy for error correction and how they're building the system. That 2029 Starling goal, it suddenly feels a bit more grounded in, actual performance measured today. Boost confidence there.
Okay, IBM provides the quantum side, and AMD, Advanced Micro Devices, ticker AMD, they're providing the engine here, right? They look like a key hardware enabler from this news.
Absolutely. And specifically, it's their FPGAs, field programmable gate arrays. This news really positions them as essential for that low latency control plane, the real-time co-processor for the quantum workflow. And this isn't just number crunching. It's about incredibly fast parallel control signals. FPGAs are just, suited for that kind of tight feedback loop needed for error correction, which is why this helps vendors like AMD who've pushed flexible accelerators as part of their hybrid strategy.
That difference, you mentioned low latency control versus just general computation, that seems important.
It really is. The timing, the immediate feedback, it's a different challenge than, say, training a huge AI model.
Okay, moving out from just IBM and AMD, what about the wider ecosystem? Who else benefits if this hybrid approach gets accelerated?
Yeah, you have to look at the enabling tech sectors. So electronic design automation, EDA, and the chip toolchains come to mind.
Why would this boost demand for software tools?
Because actually building that control logic, the stuff running 10 times faster, that's complex. It takes highly customized silicon design. It means you need more FPGA and accelerator design work, probably more complex work, than before. If you're trying to get a classical chip talking to a quantum device in milliseconds, well, you need the best design tools available.
Ah, I see. So the complexity of making the hybrid parts work together drives demand for this specialized software to design those parts.
Exactly, which points directly to the big EDA players. Companies like Synopsys, SMPS, and Cadence Design Systems, CD&S, they make the software needed to design, simulate, and verify these really intricate control boards that bridge the quantum and classical worlds.
Okay, EDA tools. Then what about the integrators? The companies putting all these pieces together into working systems? If standard silicon like FPGAs can handle this real-time job,
then the hyperscalers and the high-performance computing, or HPC builders, look well-positioned, yeah. They're the ones who already manage complex infrastructures, mixing CPUs, GPUs, maybe FPGAs, and eventually these quantum components. Microsoft, MSFT, seems like a beneficiary here. They have Azure Quantum, and they've been talking about hybrid orchestration for a while. They provide that cloud layer that hides the hardware complexity.
how hard is it, though, practically? Making a super cold cryostat talk smoothly with a standard server rack, isn't that integration piece really tricky?
Oh, it's definitely the challenge, which is why you also see potential benefit for companies like, say, Supermicrocomputer, SMCI. They specialize in building these configurable rack-scale systems for demanding stuff, like AI.
Yeah.
They seem perfectly placed to supply the actual physical racks and maybe integration services for these new hybrid nodes,
Mhm.
the ones needing these specific AMD FPGAs built in alongside regular compute.
Okay, that covers the potential winners. Let's flip it now. Who might see some near-term pressure or maybe just less positive attention from this, specifically thinking about market sentiment?
Right. This is where you see the immediate investor reaction sometimes. The dynamic is often a rotation of attention, maybe away from the really long-term pure quantum bets, towards these hybrid stacks that seem to show a clearer, perhaps nearer-term path.
So what does that mean for the pure play quantum hardware companies, the ones really focused on just making more and better qubits?
Well, they could face a sentiment headwind, near-term at least. Markets tend to like certainty, or steps towards it. So if conventional chip and FPGA here can handle a critical piece needed for quantum to work, like real-time error correction, it might make the time frame for revenue from hybrid systems seem, well, closer.
Making investors perhaps look at companies promising a breakthrough 5 or 10 years out and think, maybe there's something usable sooner with this hybrid approach.
That's the potential dynamic, yes. It could affect sentiment around pure play names, whose stories rely heavily on future qubit scaling. Companies like IonQ, and Rigetti Computing, RGPI. Their narrative, which is often about more qubits equals progress, gets temporarily shadowed by this system utility equals progress idea from the hybrid side.
And then there's just the direct competition, right? Stealing the spotlight.
Yeah, exactly. When IBM gets headlines with a measurable result like this, other companies' news, even if technically valid, might just get less attention for a bit.
Yeah.
Alphabet, GOEGL, for instance, had their own quantum algorithm news recently. But today, the buzz is around IBM and AMD. You can create a sort of challenging read-through for smaller quantum players, too. Maybe even indirectly for those linked to, say, Quantinuum, the Honeywell spinoff, through his U.S. peers.
Okay, final area. How does the focus on FPGAs here affect how people view other accelerators, especially GPUs?
Well, this news specifically highlights AMD's FPGAs in this key quantum control role. And by doing that, it kind of refines the view that maybe GPUs are the only accelerator that matters for all advanced computing tasks.
So where does that leave NVIDIA? Their name is almost tied directly to acceleration these days.
Look, GPUs are still dominant for massive parallel tasks, like training AI models, no question. But when a specific critical function needs that ultra-fast, low-latency, customizable control the kind of FPGAs are good at, it shows there's a clear need for different types of hardware. So AMD's success here, carving out this important niche in the quantum stack, it naturally softens the idea that every tough workload just automatically goes to a GPU. It's more nuanced.
And what about others in the ecosystem who maybe bet heavily on just the general GPU trend?
Right. That could affect, say, ARM-only ecosystem players, maybe cloud firms or leasing companies whose main angle is renting out standardized GPU compute power. If the cutting edge of quantum needs these specific integrated FPGA stacks, those general-purpose providers might see a bit less incremental buzz compared to the custom builders highlighted by this news. It's sort of specialization versus generalization. Okay, so let's try to summarize the takeaways for you, the listener, thinking strategically. First, time horizons. Seeing error correction run on standard AMD hardware suggests that hybrid systems capable of generating revenue might be closer than some thought. You'd want to watch for actual follow-through contracts or reference designs from IBM now.
And second, follow the money. Look at the capital expenditure, the CapEx mix.
Exactly. Where the budget's going. You might expect spending to lean more towards these enabling parts. FPGA control racks, the EDA software licenses, complex integration services.
Yeah.
The spending on the actual quantum hardware itself might be relatively more measured in the near term, while the industry nails down this crucial classical control part.
And this whole story does suggest a potential trading angle mentioned in our material. Maybe favoring the hybrid enablers versus being more cautious on the pure play quantum names, particularly on days when news like this breaks. But a word of caution is always needed. Sentiment can turn quickly. Next day reversals are possible if competitors release their own data points.
Yeah, definitely. And maybe one final thought to leave you with, building on this integration theme. This success story with classical and quantum working together, it shows that useful quantum computing isn't just about the qubit itself, Perhaps the whole definition of quantum supremacy eventually moves away from just counting qubits and focuses instead on, provable speed on real applications achieved through this kind of smart error correction in system design. Something to think about.
We remind you that this discussion is not financial advice or a recommendation to buy or sell. This content is purely the opinion of the author of the material reviewed.